Hello, everybody. I'm back. It is what night? Thursday night. And you know what that means? There's another show of Minutes with Milo. Yay! Glad we could be here. Looks like it's going out on the wavelengths. All right, let's reset that so we can tell when our junk is falling apart. Let's get that mustache all cut back. You want to be able to see the words as they come out of my mouth. How about this hair? April 20th, 22nd, somewhere around in there. Remember that? 2024? Buzz. Shaved it all off. Now look at it. Coming back beautifully 4 months later. And it's hot. Why is it hot? Because of the weather. That's right. My hair is hot because of the weather. And it makes my head hot because of the weather. It makes this stuff run down my face when I'm really hot. Why? Because of the weather. Why did I do this show tonight? Because of the weather. There's Roberto. Roberto's here because what? The weather. That's why he's here. He wants to know why it's so dang hot. It's so dang muggy, humid. I don't know why it is, but we're going to find out when them weathermen talk what they're trying to tell us and how much mumbo jumbo is in that gumbo. So that's why tonight's show is about weather jargon, weathermen speak, all these terms, and we'll look at some of them, but some of them are really confusing. I mean, some of them make sense, right? Some of them don't. Some of them you hear all the time and go, what does it matter? Tell me what tomorrow. Is it going to rain tomorrow? What's the percentage? Do you know what you're talking about? And so we'll look at some of that. But first off, welcome to the channel. Welcome to the live show if you're watching it live. Robert Garthok is. He's here live. You could be too. You just have to tune in to Gumbo Yummy. I know. I don't know if I've ever had really what you'd consider gumbo. But anyway, back to why you should subscribe to the channel. Because then you don't miss an episode or a broadcast. Because I'm a broadcaster. I've decided that I'm a broadcaster. And you need to turn into the broadcast live. So maybe you can interact with the fine folks that join us here. And you subscribe and turn the little bell thing on when I post on YouTube that it's getting ready to start. You'll know about it. You'll go, daggone, there's that interesting Minutes with Milo show. I got to tune in. But if you don't, that's okay. Watch it later. I don't know. If you need something to help you put to sleep, put on my playlist and let it roll. Slumberland is sure to follow. I hope not, but you know. So, weatherman terminology. Weather person terminology. How to predict the weather. Robert says he's ordering pizza. Is it gumbo pizza? I wonder if gumbo pizza, isn't gumbo like it's like a soup or something, right? So it's floating around in this dirty water so you can't really see what it is and you just kind of, eat it. Isn't that gumbo? Or is it more thick? Maybe I'll do a show on the difference between soups and broth. No, what would you? Stews. Is gumbo more of a stew than a soup? Maybe one day I'll put out one. The gum in gumbo is what it does to your tummy and your insides. It gums them all up. So maybe one we'll look at here. Soon we're looking at terms. Is gumbo a weather term? Maybe I can sneak it in on tonight's show and talk about, gumbo, what it means. Maybe it's raining gumbos instead of cats and dogs, frogs and toads. Well, look at that. I have heard tell that it could not necessarily rain, but Robert says it's like seafood gravy with rice. Okay, that might not be too bad. That it has rained aquatic life. Maybe not frogs, maybe fish. I'll look at that maybe in a minute. We'll look at why that might be possible. You know, it just doesn't seem possible, but it might be. I'll tell you why. All right, so I picked out a couple. If you saw it, and you can't probably read it because I do crayon art as my thumbnails for these shows. And is this in the correct ear? Is that better? I think that's better. I think my left ear is my better ear. That's one I use to talk on the phone all the time. That's probably why eventually, you know, get some kind of weird stuff going on up here because you've got your cell phone, your radioactive microwave generating, read your mind device plugged into your head. So, me and Craig at work, they talked about this because what do these people mean by this? And the first thing I think came to mind was relative humidity. We all know what, we'll look at it. We kind of have an idea of what humid is or humidity is. It's moisture in the air. And so when it's warm and there's a lot of moisture, a lot of humidity in the air, it makes it feel warmer because it kind of just, you kind of feel it. And it could be the same temperature, but the humidity is low and it doesn't feel so bad. That's why I like in the desert areas, it might be well into the 90s, but it doesn't feel too bad because the humidity's low. Garthok wants to know what it means to be under the weather. What's weather got to do with being sick? All right. You pose a good question. Let's see what it says. Now, I'm not going to show you this right now because that's a lot of messing. We'll mess with it here in a minute. Where? Do you want to know where it got started? Or what it means? Well, I mean, yeah. We know it means that you're sick. Where did the term under the weather start? Language of sailors. Well, I'm glad I'm not showing this. We might have to cut the show quick because of the censors. All right. Linguist Richard Lederer tells us that under the weather, meaning you're feeling sick or ill, comes from the language of sailors. On the high seas, when the wind would start to blow hard and the water became rough, crewmen and travelers would go below deck and down to their cabins in order to ride out the storm and avoid becoming seasick. All right, so let's see what the Farmer's Almanac has to say about it. Oh, you know what? It just quotes what I just read you. So that's not a different explanation. My click-happy butt just closed that window. So there you go. That's about as far as I could get you, Garthog, before I screwed it up. It's all about sailors. So, under the weather. So when the weather got rough, the boat was under the weather. It started rocking really bad. People would go under the deck, below deck, so they wouldn't get sick. Now, why is that? And I can tell you from experience, that when you go out on the ocean or places that have waves, maybe the Great Lakes, it doesn't have to be an ocean, okay? You know, your eyes and your brain and your ears have to be working in conjunction or things go south. So when you're on the waves and the boat's going up and down and sideways all at the same time, and your ears kind of trying to keep up with that, and your brain and eyes are going, are we sideways? Are we straight up? Are we halfway down? What's the story? We're going forward, we're going back. You know, you get motion sickness or seasick. So that's when you're on top of the water and you're subjected to that, the full deck. You know what I mean? It's like leverage, that whole thing. And the further you go down in the ship, you kind of get under the water, and it's not as pronounced if you can get below, I think, if you get below the water level. So if you went scuba diving, just tell this story. Went scuba diving to get my certification. We go out about a mile or two off the coast. It wasn't bad, but for me, a landlubber, it's bad. So you start feeling bad when you're sitting still. You know, when you're going along in these little boats and it's just meow, 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 and you kind of, you know, you're riding on something, you know, your body's used to that. But when you stop and that boat's going all kinds of different ways, you start feeling bad. But the minute you get in the water, you stop all that and you just kind of, you know, people are used to waves and stuff, bouncing up and down or riding the waves in the water. You start feeling better, and that's exactly what happened. Was it took away that conflict between your brain, your eyes, and your ears, and it just said, "Oh, we know what we're doing now. You know, this is okay." So I can say from experience that if you get seasick and you can, don't jump off your stupid, you know, ocean liner because you're feeling bad. But if you can get in the water and get away from a lot of that tippy turny stuff, you'll feel better. Or throw up 7 times, or just wait till your mind and your body and everything gets accustomed to that, and it, you know, it's eventually it will, and it'll go away. Or take medicine, or take these oils you put on your wrists and behind your ears, all that stuff. They got some pretty good stuff, I guess, for seasickness. You get keel haul. No, we don't want a keel haul. Sailors are true weathermen. Yeah. Take that, Dave Dirks. I started to do a show on computer modeling. Not like I want to make a figurine, you know, a little mouse. Let me get over here where you can see my fingers. A little mouse, not like modeling like clay, but modeling like feeding the computer something and saying, what do you think is going to happen? And I think that's what they do with weather. They use all these computer models. It says, well, based on the facts that you've given me, I've concluded that it will rain from this time to that time. And, you know, so they kind of play with the model and think, well, that's maybe good, but I noticed this and I noticed that. Maybe I don't trust weathermen very well, or weather people, or people that say they can, you know, forecast weather. Now, sometimes they're pretty good. Sometimes they're pretty good, but today, for an example, it was hot, and I thought I heard thunder. And I could see, you know, well up into Virginia, that it was dark. So I jumped on my phone and said, is it going to thunderstorm? No, 15% chance of rain. All right, show me the radar. Pull up the radar. Now, I didn't look at cloud cover. I started to change it, but I did. I looked at storms, and well into Virginia, there was a storm, and it was pretty significant. Well, I mean, you know, I said, okay. So I went through the whole day and didn't get rained on. I come home, guess what? It rained. My grass is wet, driveway's wet, cars are wet. Now, how heavy did it rain? I don't know. But where I was, the weatherman predicted it goodly. If I'd been home, the weatherman predicted it poorly. So, but I would say it's hard to be a weatherman. Back to the terms. We're going to look at relative humidity. So, let me get that set up. Let me change this over here so I know what I'm looking at. There it is. All right, window capture. Change that to this. Look at there. Okay. Now I need to get rid of some of these things. I don't know what I can get rid of. It makes it hard. So you click in this window and you drag and minimize and resize windows on this one side. There it is. So I shrink my picture down. And now bring up the window capture, and then I push this button. Presto changeo, you get to see it. See how that works? Is that like who's kin to humidity? Like cousins and such. Nope, 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 nothing like that. Nope, nope, nothing like that. I say that, but all that's relative. See what it is? It might be. Humidity and relative humidity are closely linked, like blood brothers, I would say. Cousins. No, you weren't Hall. I was messing with you. I was just messing with you. Okay, humidity. Here we go. Humidity is the concentration of water vapor present in the air. Water vapor, the gaseous state of water, okay, is generally invisible to the human eye. Now, I might say steam is water vapor, and you can see steam, okay, like in a steam room, or you're making, tea on the stove and steam comes out, or you're boiling water to boil an egg and steam comes up. I don't know what that humidity, that might be like over 100% humidity. Can you have over 100% humidity without it raining? But I beg to differ. You can see some humidity. Oh, yep, we're going to look at dew point. That was one that's kind of confusing to me. Relative humidity is kind of confusing. All right, humidity indicates the likelihood for precipitation, dew, or fog to be present. Makes sense. Dew is water vapor collecting. Fog is water vapor in the air. Now, see, you can see fog, and it's not steam. Sometimes fog is cool, like swamp humidity in your drawers. Could be. Well, we won't go there to check it. Maybe you could get you I've got a thermometer. I'm going to get a bunch of them because they're cheap. And they're like little digital thermometers that tells you what the temperature is and the humidity is in your room. So I got one downstairs when I put in a dehumidifier, and I thought, oh, what? Does this thing really? I mean, I know water gets in the bucket, so you got to assume it's working. But I wanted to know, so I put this thermometer, had the humidity thing on it, and it has a little chart, what's high and low and normal and all that stuff. So since I didn't have one in the basement for a long time, the humidity was pretty high this summer. I got one and let it run continuously until it fills up, and I dump it out and it starts all over again. But it got down to 44% humidity in my basement, which is good because I got a lot of stuff down there and I don't want it to mildew and rot. And then right now it's about 48%, which is right on the normal range. And I don't know why it went up. I mean, I know it's humid outside. All right, back to the definition. Humidity depends on the temperature and pressure of the system of interest. I just want to know why it's, muggy outside. The same amount of water vapor results in higher relative humidity in cool air than warm air. A related parameter is the dew point. There you go. Let's just skip to Mm, mm, absolute. All right. Absolute humidity is the total mass of water vapor present in a given volume or air or mass of air. It does not take temperature into consideration. Absolute humidity is the atmosphere ranges from near zero to roughly those are grams and ounces per cubic meter when the air is saturated at 30 degrees Celsius or 86 degrees Fahrenheit. Okay. Absolute humidity is the mass of water divided by the volume of air, which is expressed as, let me highlight this because those numbers things are missing. I don't get it. Why are there's no thing? Can y'all see that? There's no. Sometimes because I turn I've got this thing on dark mode, the browser. Sometimes darker colored text don't show up. So if you highlight it, it usually shows up, but there's nothing there. Can you plug numbers into that? Nope, nope, nope. Can't plug numbers into that. All right. Absolute humidity is the mass of the water vapor divided by the volume of air and water vapor mixture, which can be expressed as whatever number. If the volume is not set, the absolute humidity varies with changes in air temperature or pressure. Because of this, it is inappropriate for computations in chemical engineering such as drying. Oh, blah, blah, blah. We're not in chemical. Here we go. Relative humidity. Relative humidity is the ratio of how much water vapor is in the air to how much water vapor the air could potentially contain at a given temperature. All right, does that make sense? I'll read it again. Relative humidity is the ratio of how much water vapor is in the air to how much water vapor the air could potentially contain at a given temperature. This varies with the temperature of the air. Colder air can contain less vapor, and water will tend to condense out of the air more at lower temperatures. So changing the temperature of air can change the relative humidity even when the absolute humidity remains the same. All right. Absolute humidity is the total mass of water vapor present in a given volume or mass of air. It does not take temperature into consideration. So what I take away from that, the only thing that sticks in my whole brain about that is relative or absolute humidity does not care about what temperature is. Relative humidity does care about what the temperature is. So relative humidity varies with the temperature of the air. Colder air can contain less vapor, and water will tend to condense out of the air more at lower temperatures. So changing the temperature of air can change relative humidity, even when the absolute humidity remains constant. "100% is the most." Can you have more than 100%? I don't know. Maybe. Chilling air increases the relative humidity and can cause water vapor to condense. If the relative humidity rises over 100, oh, that's the dew point. Likewise, warming air decreases relative humidity. Warming some air containing a fog may cause that fog to evaporate. Okay. So if you get, your windshield is foggy in the morning and you turn on the heater and you blow heat onto the windshield, clears it right up. Warming some air containing a fog may cause that fog to evaporate, as the droplets are prone to total evaporation due to the heat. Relative humidity only considers the invisible water vapor. Mists, clouds, fogs, and aerosols of water do not count towards the measure of relative humidity of the air. although their presence is an indication that a body of air may be close to dew point. Well, I think what it's saying up there is if the relative humidity rises over 100%, the dew point. So we'll look at dew point here in a minute and keep, so it goes up to 99 and it hits 100%. The air is totally saturated, I would guess, and then anything above that potentially creates dew or water condensation that then you would see, because then the water gets, I guess, too heavy and falls out. Let's see. Relative humidity is normally expressed as a percentage. A higher percentage means that the air-water mixture is more humid. At 100% relative humidity, the air is saturated and is at its dew point. In the absence of a foreign body on which droplets or crystals can nucleate, the relative humidity can exceed 100%, in which case the air is said to be supersaturated. Introduction of some particles or a surface to a body of air above 100% relative humidity will allow condensation or ice to form on those nuclei, thereby removing some of the vapor and lowering the humidity. All right, so if the water has no place to go, it can exceed 100% relative humidity, not absolute humidity. It cannot, but math can prove it does. I know it. Math is a constant until it's not, right? Relative humidity is an important metric used in weather forecasts and reports, as it is an indicator of the likelihood of precipitation, dew, or fog. In hot summer weather, that's us, a rise in relative humidity increases the apparent temperature to humans and other animals by hindering the evaporation of perspiration from the skin. That's why it feels muggy. All right? I must be thinking about work. I only go maybe 60%. Oh, go 60% of work? Go 60% of work? 100% humidity would be underwater. Yeah, you could say that. According to this, if it doesn't have any place to attach to, the humidity in the air will, breach 100%, and it's called supersaturated. So, where were we? As an indicator, like in hot summer weather, a rise in relative humidity increases the apparent temperature to humans and other animals by hindering evaporation or perspiration from the skin. For example, according to the heat index, something else, a relative humidity of 75% at air temperature of 80 degrees Fahrenheit would feel like 83.6 plus or minus 1.3 degrees Fahrenheit. How do they know how you feel? That it feels different. But it's true. It does. I'm just making a point. Nobody knows how, if I feel hot or cold. But I alluded to that at the beginning of the show. So when the relative humidity is high and it's 90 degrees, you can tell it's really warm. Like today, the humidity or relative humidity wasn't very high, or it wasn't as high, and it was 91 degrees. Well, it didn't really feel 91 like it has other days because the humidity wasn't so high, or relative humidity wasn't so high. The only thing we have to do is figure out a way to remove the humidity from the air, and we'll never be hot. That's what I'm thinking. But it makes sense. So the body sweats. That's what that stuff was running out of my eyes I was talking about earlier, running out of my hair because my head's hot, because I got all this hair now. And evaporating the sweat is what cools the skin in your body. So if there's a lot of humidity in the air, it's hard for your sweat droplets to evaporate and cool your body. When there's less humidity in the air, then your sweat droplets evaporate easily off your skin and they cool you quicker. Yep, it was nice and hot today. I like it hot. I'm not super crazy about humidity, but what I do like beach weather. And so lately we have been getting a lot of beach weather. That's one of the reasons I like it when it's hot and humid, because I just can go to my happy beach place in my head, and the weather helps you make you feel like, man, this is just like being at the beach. I can almost hear the ocean, the waves crashing on the beach, and then you have to go pull a toilet or something. But that's the reason I like the hot. And yeah, I feel hot and I sweat and all that stuff. But I'd rather do that than be chilled. I have a hard time getting warm. If I get chilled, it's done. I'm done. Relative humidity is also a key metric used to evaluate when it's appropriate to install flooring over a concrete slab. So your floor man must be part weatherman. Relationship between absolute humidity, relative humidity, and temperature. So let's look at this chart. Relative humidity, then temperature along this side. Let's find out where we were at today. Well, why is this? Okay, never mind. Centigrade. Where were we? We were between 86 and 95 today. The van kept saying it was 91. I don't know what the relative humidity was today. Relative humidity, TY, Bristol, Tennessee today. I spelled today right? I did. Now see, this just says that the humidity was 73. It doesn't give me the relative humidity. The wind was 2 miles per hour. That's not a beach wind. We need it. Wind should be at least 5 miles an hour to give you that good cooling, evaporate your sweat beads kind of cooling. But it said it was 73% humidity today. But that doesn't plug into the chart because we're dealing with relative humidity. Over here, down to here. What are we calculating here, people? So this, if I'm reading it right, made it feel like 3/4. It wasn't 95, but it was, it was closer than 86. So 70% humidity makes it feel like it's 3/4 of a degree hotter. Is that what I'm calculating? Oh, this is at sea level. Hey, we're not at sea level. All right, so absolute, relative humidity, absolute humidity, relative humidity, specific humidity. Specific humidity or moisture content is the ratio of mass of water vapor to the total mass of air parcel. Specific humidity is approximately equal to mixing ratio, which is defined as the ratio of the mass of water vapor in an air parcel at the mass of dry air for the same parcel. As temperature decreases, the amount of water vapor needed to reach saturation also decreases. As the temperature of a parcel of air becomes lower, it will eventually reach the point of saturation without adding or losing water mass. term relative humidity is reserved for systems of water vapor in air. The term relative saturation is used to describe the analogous property for systems consisting of a considerable phase other than water in a non-condensable phase other than air. What? What? The device used to measure humidity of air is called a psychrometer or hydrometer. A humidistat is a humidity trigger switch that often used to control a humidifier or dehumidifier. Gotcha. I've got one of those. I've got one of them switches right there. I've got a humidistat. I've got one of those. All right. So basically, if it's more humid and relative humidity is high, then it's going to feel hotter. Let's just put it that way. All right. It talked about this. We're going to look at it. Dew point. This is another thing that me and Craig looked at. Dew point. The dew point of a given body of air is the temperature to which it must be cooled to become saturated with water vapor. Now, we talked about that or read about that. So, you can have a certain amount of water vapor in the air, and as you lower the temperature of the air, does that increase or decrease the dew point? Okay. But the lower the humidity is, yes, there's where we need to start studying weather. Humidities. The dew point of a given body of air is the temperature to which it must be cooled to become saturated with water vapor. This temperature depends on the pressure and water content of the air. When the air is cooled below the dew point, its moisture capacity is reduced and airborne water vapor will condense to form a liquid known as dew. When this occurs through the air's contact with a colder surface, dew will form on that surface. The dew point is affected by the air's humidity. The more moisture the air contains, the higher its dew point. So when the temperature is below the freezing point of water, the dew point is then called the frost point, as frost point is formed via disposition rather than condensation in liquids. The analog to the dew point is the cloud point. Huh? Cloud point. I guess it makes clouds at a certain point, right? I wish they gave good examples. Let's see if we can give me an example of dew point. All right. The dew point temperature will always be lower than or equal to the air temperature. For example, let's say your weather station records an outside temperature of 50 degrees Fahrenheit and a humidity reading of 80%. The temperature at which these two values intersect is the dew point. I hope this gives us a picture. Ooh, here we go. Look, pictures, people. Oh, quit it. I'd like to have a weather station, but I'm not interested right now. Thank you very much. We get pictures. Look at all that. There we go. The temperature to which these two values intersect is the dew point. In this example, dew will begin to form at 44 degrees Fahrenheit. All right, so they give you an example. It's 50 degrees outside. You have 80% humidity. It doesn't talk about relative humidity. It says humidity. I hope they're not like using these terms interchangeably, because that drives me crazy. The temperature at which these two values intersect is the dew point. Well, in this case, it's 44 degrees. So you're sitting in your car. It's 50 degrees outside. You haven't started it. It's in the morning. If something happens, you're sitting there. If something happens and it goes from 50 to 44 degrees, you're going to get dew forming on your car. Now, if it stays above 44 degrees, that doesn't happen. So, if you go out in the morning and there's no dew on your car, then it didn't reach the dew point. It didn't get cool enough in the nighttime to make the moisture in the air condense onto your cool car, your car. Why do I care? How did they read my mind? Why do I care? When the air temperature equals that of the dew point, which is a relative humidity of 100%, there you go, Garthog, 100%, clouds and fog may begin to form. If the air temperature continues to get cooler, the water vapor will condense and drop out of the atmosphere as precipitation or dew. During warmer seasons, the dew point temperature can be a good indicator of how humid the outside air feels, as well as how likely it is to rain or storm. From gardening to lawn care to enjoying the backyard, it is important to know the dew point conditions right in your own backyard, and wireless weather stations from Accurate. Learn about the different weather stations offered right here at Accurate Olympus Series. They may have one that would allow us all to become good weathermen, right? What's the difference between fog and mist? Is fog just missed opportunity? I'm going to have to do another show on dad jokes. I love me some dad jokes. They're so dumb, they're cute, they're funny. They just make you smile. I'm not saying that that was a good dad joke, but it made me smile. Fog is just a missed opportunity. Yep. Yep. Misted. It should have been MISSEDDDD, but I got it. So hopefully other people will get it. So here's our pictures. In this image, it doesn't look like an image. To me, an image is a picture. Hello. All right. In this image from the National Weather Service, you can see the surface temperature is 92 degrees Fahrenheit. Is much warmer than the air where clouds form, 60 degrees Fahrenheit. This is because the air temperature typically decreases with height. You also see the dew point is always 60 degrees Fahrenheit, showing the amount of water the air can hold at that time. So the upper air temperature is cool enough to match the dew point temperature, allowing for condensation to occur and clouds to form. With this example, you can see the daytime temperature at the surface is 92 degrees. Well, let's imagine the overnight low drops to 59 Fahrenheit. Since the dew point temperature is still 60 degrees, you can see dew form on the grass when you wake up in the morning. It would again dry out as the surface temperature increases during the day. When temperatures are below 32 degrees, frost forms instead of dew, so we call it the frost point. All right, see, I like pictures. Here, let's get rid of that. Nobody's calling, so we don't need that. There we go. Got rid of the phone. Oh, geez, we're over here, dummy. There, that controls the up and down. All right, so surface temperature down here is 92 degrees, and its dew point based on its humidity or relative humidity is 60 degrees. That's its dew point. Well, as you go up the mountains are 76, but it's still not the dew point. You go up to 6,000 feet where the temperature is 60. Now it hits the dew point. So guess what? A cloud is formed. You can view your dew point temperature calculations from your accurate outdoor weather sensors. You could. The accurate atlas says partly cloudy, temperatures 58.2, the winds from 6 miles per hour from the northwest, 0% inches in rainfall. Humidity 73%, pressure is 30. We'll look at that next. Is biometric biometric pressure. Dew point says 50, feels like 57 because of the humidity or relative humidity in the air. 7 degrees seems like a lot for it to change. All right. So dew point, that's the temperature at which dew comes out. The water vapors come out of the air. Make sense? Not really. Not really. Let's get that. What are we looking for? Yes. Let's go back to the little grass shack. Dew point explained. What is it we're looking at now? Biometric. Is it biometric? Pressure? Oh, explain that to me. There it is. Barometric, not bio, you big dummy. Barometric pressure. There we go. Barometric pressure, as known as atmospheric pressure, is the force exerted by the weight of the atmosphere on the Earth's surface. It is measured in units of pressure called millibars or inches of mercury. I've heard that. Why do you do that? Before you do that, let's get over here to the well-known Wikipedia. Atmospheric pressure. Atmospheric pressure is known as air pressure or barometric pressure. After the barometer is the pressure within the atmosphere of Earth. The standard atmosphere is a unit of pressure defined as 14.696 psi. Had to go through all that other junk. 14.69 pounds per psi. So what that tells me is that if you go out and you stand and you're on ground level and you're at the ATM, which was the what did they say the ATM is? Just the standard atmosphere. If you're just standing on the ground, you're at standard atmosphere. The atmosphere weighs on your body at 14.696 per square inch. So you're a pretty strong fella if you can stand there with 14.696 pounds of atmosphere resting on you, every square inch of your body, just pressing in on you from all directions. Maybe that's what gravity is the pressure of the atmosphere just holding you to the ground. But I know this from scuba. I think it's ever 13 feet or 15 feet? Let's see, at what depth does atmospheric pressure, what do they call it? ATM? At what depth does pressure increase while scuba diving? 10 meters. 14 and a half. Let's see. $10 meters. What's that in real feet? I was thinking it's about 12 feet. For every 10 meters of depth, the pressure increases by 1 bar or 14.5 psi. That means that on a dive 20 meters around 60 feet below sea level, there would be water pressure of 43.5 psi, 3 times greater than the air pressure at Earth's surface. Pressure at the base of a 10-foot column of water would be approximately 139.6 pounds per square inch. Don't ever get under a 10-foot column of water then. That's some pretty heavy stuff. I wish they told me, is it a meter? 10 meters. Oh, why don't you do this? Meters to feet. I can't calculate. Meters to feet. Length. Meters. 10. Huh. All right. So whatever, 32 feet. I thought it was quicker than that. You didn't take scuba. I took scuba and there wasn't any left. So every 32 feet, almost 33 feet. As you go down in water, it increases 1 atmosphere. So yeah, that's pretty heavy stuff, man. Oh, let me do this real quick. 51 minutes. We did this in elementary school. Do it yourself. DIY. That's it. Do it yourself. Barometric barometer. BR. Here we go. How to make a barometer for your kids. Little picture. There it is. So what we did in our elementary school, we took a mason jar, I think it was a mason jar or a cup, and stretched a balloon over it, right? Glued a stick to it just like this. And I don't remember if we put numbers on it, but I think we just had it marked so we would know it was going up and down, up and down. Because this would have to be calibrated exactly to the, whatever barometric pressure was. So if it went up a little bit, it actually went up 1 barometric pressure. What are some of these things? What are they doing here? Simple science for kids. All right. So we did that in elementary school, and you get to watch it throughout the day because, the barometric pressure changed, and everybody's, I know you've seen those where the temperature's on one, barometric pressure's on one, and the humidity's on the other. That, if you had one of those, you could predict the weather at your house. I bet you could. If it was kind of effective. All right. Mechanism. Atmospheric pressure is caused by the gravitational attraction of the planet on the atmosphere gases above the surface and is a function of the mass of the planet, the radius of the surface, and the amount and composition of the gases, their vertical distribution in the atmosphere. It is modified by the planetary rotation and local effects such as wind, velocity, density, variations due to temperature, and variations in composition. Wow. The altimeter setting in aviation is an atmospheric pressure adjustment. Average sea level pressure is 1,000. Oh, what is it? Give me that. Oh, you killing me. Again with the daggone inches per something. Weather reports transmitted around the world in hectopascals or millibars, except in the United States, Canada, and Japan, where it's reported in inches of mercury in 2 decimal places. The United States and Canada also report sea level pressure, which is adjusted to sea level by a different method. In the remarks section, not in the internationally transmitted part of the code, in hectopascals and millibars. Jeez almighty, hecko Pete, man. Surface pressure is the atmospheric pressure at a location on Earth's surface. We're getting off that. You're killing me. Let's see. We looked at barometric pressure, humidity, relative humidity, absolute humidity, and dew point. So I think we all know what temperature is. So if you know temperature and you know dew point and you know relative humidity, and barometric pressure is thrown in there. We didn't look at it much. You could probably predict when a storm was coming, right? So old people say, "Oh, my bones and my joints ache and stuff." Well, that was probably because of, maybe the barometric pressure was going up. There was more or less humidity in the air, affected the arthritis, and so they knew it was going to rain because that was an indication that the conditions were getting correct to have rainfall. They didn't know why. They just knew that when their shoulder hurt or their elbow hurt and they felt kind of achy, that it was probably going to rain. Which is okay. I mean, it's all biology, barometric biology, right? So we didn't look at all. I guess this is basic. There were so many. I started to just look up basic terms, and there were so many of them stupid things. I thought, well, you know what? Most of the time in a weather report, you hear about, barometric pressure, high or lows, systems coming in, or you hear the dew point for tomorrow, or you hear, relative humidity or humidity today is this, this, this. So those are the big ones to me that they just talk about. And apparently they do that because it's a good indication on whether it's going to rain or not. So anomalies, in the basic terms of common climate and weather terms, I don't no weatherman hardly ever that I've heard talks about anomalies. No, maybe pressure. He doesn't talk about aurora borealis around this place. Blizzards, not so much. Circulation, yeah. Climate, they just use that. Cold front, they use that a lot. Cold front's a narrow transition zone separating advancing cold air from retreating warm air. The air behind a cold front is cooler and typically drier than the air it is replacing. Interesting. Cyclone. Dew point. Dew point is the temperature to which air must be cooled for water vapor to condense and form fog or clouds. Or dew. Hello. We all know what a drought is. El Nino. Evaporation. We know what that is. Flurries. Fog. Fog is water that has condensed close to ground level, producing a cloud of very small droplets that reduces visibility to less than 3,300 feet. Wow. Interesting. That looks more like snow than fog. Humidity, the amount of water vapor in the air, Indian summer. What about, blackberry winter? Jet stream, El Nina, Tornado. Oh, okay. Quick thing about raining cats and dogs. Has it ever rained animals? Talked about this at the beginning of the show, and I'll tell you why. That tornado made me think about it. All right. Raining of animals. Has it ever rained animals? All right. Wikipedia, of course. A rain of animals is a rare meteorological phenomenon in which flightless animals fall from the sky. Such occurrences have been reported in many countries throughout history. One hypothesis is that tornadic waterspouts sometimes pick up creatures such as fish or frogs and carry them for up to several miles. However, this aspect of the phenomena has never been witnessed by scientists. In history, rain of flightless animals and things have been reported throughout history. In the 1st century AD, Roman naturalist Pliny the Elder documented storms of frogs and fish in 1794. In 1794, French soldiers saw toads fall from the sky during heavy rain in La Lina near the French city of Lille. Rural inhabitants in Yoru, Honduras claim fish rain happens there every summer, a phenomenon they call something something. Although the name may be indoctrination from a Spanish missionary, as the fish have only been found near tributaries after the storms. So a French physicist he lived from 1775 to 1836, was among the first scientists to take accounts of raining animals. Addressing the Society of Natural Science, he suggested that at times frogs and toads roamed the countryside in large numbers, and that violent winds could pick them up and carry them great distances. After a reported rain of fish in Singapore in 1861, French naturalist Cousteau speculated that a migration of walking catfish had taken place, dragging themselves overland from one puddle to another following the rain. No, thank you. The likeliest explanation for many of the supported cases is that there is no falling happening at all and the animals are driven along by winds or a deluge of some sort. This explanation also accounts for the prevalence of reports that only a single species or type of animal was ever reported raining from the sky. See, I like the water spouts. A water spout that forms over water. Under this hypothesis, a tornadic waterspout transports animals to relatively high altitudes, carrying them over large distances. This hypothesis appears supported by the type of animals in these rains, small and light, usually aquatic, and by the suggestion that the rain of animals is often preceded by a storm. So that was the thing. It sucks up water in these, or water and fish and aquatic life in these water spouts, takes them up into the atmosphere, holds them up there, and then when it's, too much for it to carry anymore, things start falling out of the sky. So even though I don't think it's ever rained cats and dogs, apparently people have reported toads and frogs and fish. So all kind of aquatic animals. So no raining cats and dogs. Fish and frogs only. No cats and dogs were harmed during this storm. All right. So did we learn anything this time? I think we did. We learned that if you want to be a weatherman, you got to know about humidity, relative humidity, barometric pressure, dew point, and how to run computer models, and you're done. Right? You could be Dave Dirks. Apparently Garthog wants to be better than Dave Dirks. So he's going to get a weather rock, and he's going to give us weather forecasts from the near and area from where he works and travels. Well, you could have different weather rocks, couldn't you? Well, you don't have to be subjected to one, or you could carry it if it's small, you could carry it in your pocket, and then you could predict the weather wherever you went. That would be good, would it? That would be good, I think. Then you could become famous. Famous Amos and his weather rock. Why would you do that to me? Snap to the grid. There we go. All right, I'm back. Big again, big head, big hair, big everything, big mouth, little shoes. All right. Thank you, fellas, for coming around and learning all about, what, 3 weather terms, maybe 4 weather terms? Who's playing with the hearts, man? Let's play one of those. Oh, I can't do that. Oops. I know, I closed it out because I messed with it. There it goes. Oh no, what happened to all the chat? There it goes. There it is. Woo. All right. Tune in next week for another Thursday night episode of the Minutes with Milo show. We'll talk about something equally boring and unimportant. But you'll learn something. You learned something about jellyfish last week. You learned something about rain. And jellyfish are wild. Well, what do we call them? Sea jellies. Not jellyfish. Sea jellies. Sea jellies are wild. What time's it getting to be? Oh my gosh. Just about past my bedtime. Just about past my bedtime. 10:08. I'm gonna sleep good tonight knowing I don't have to get up early in the morning. Cross your fingers that it stays that way. All right. If you watched the whole thing, I appreciate it. If you watched part of it, then you're not seeing me thanking you for watching part of it. If you were here live, thank you very much. Come on back next Thursday. We'll do it again. Until then, leave me a comment. If you watched part of it, you hated all of it, tell me that. That's fine. I don't care. I want to hear your input. That doesn't mean I'll take it to heart. So, stop streaming. Here we go. Let's try this again. We're going to say goodnight, everybody, and then we'll push the button, and it'll say, are you sure you want to do this? Yeah, I know I won't be able to reconnect. I guess